Math 3, Lesson Summary Video. Bike Lovers. This lesson is a Solidify Understanding task, which takes concepts developed previously and helps you formalize those ideas. The purpose of this lesson is to graph and evaluate piecewise functions, given the equation in function notation, and interpret them in context. Let's check out the situation. Michelle and Rashid love going on long bike rides. Every Saturday, they have a particular route they bike together that takes 4 hours. Below is a piecewise function that estimates the distance they travel for each hour of their bike ride. So we have a piecewise function. We learned yesterday that this was a piecewise function. It has 4 pieces for 4 intervals of time. We know our time is in hours. We do not know, it does not state here what we're measuring our distance in. So we'll want to keep that in mind as we answer our questions. What part of the bike ride are they going the fastest and the slowest? Well, this is going to make us dig back into our Math 1 knowledge. If you remember, fastest, slowest, when we're dealing with fastest and slowest, we're dealing with rates. And in these equations, our rate is going to be our slope. So we need to identify from the slope what was our fastest time interval and what was our slowest time interval. When I look at these, I see a slope of 16, a slope of 10, a slope of 14, and a slope of 12. So of those, I notice that the biggest one, the fastest, is going to be the first one, and the smallest is going to be the slowest, and that's actually going to be the second one, which would make sense because that means they rode fast for a whole hour, and then they were probably tired. So they probably had to slow down a bit to kind of get their breath back. So if we're looking at this yesterday we mentioned was the inequality notation for showing an interval. So maybe we'll use interval notation down here to show our interval. So the fastest went from 0 to 1. Notice that I used the brackets because this was an equal to and this was an equal to. So we do want to include the 0 and include the 1. For the slowest, we want to go from 1 to 2, but notice the 1 is not included. Now, the reason for this is that 1 was included here. You don't want to include it in 2 intervals because then you might run into some problems with it being a function. But it goes all the way up to 2, and 2 was included. So when you do interval notation, they don't both have to be the same thing. It depends on whether it was equal to or not equal to. What is the domain of this function? Domain is the input, and it's the input for the entire function. Notice that this function only includes intervals from 0 to 4. Now 0 is included, and 4 is included, but we don't have anything else involved. So we do want to go from 0 to 4, and we will include both of those. Find f of 2. So remember function notation, the number that's inside the parentheses is what you need to input into the function or substitute into the function. When you're using a piecewise function, don't forget that first you have to choose which interval does that input belong to. So where does 2 fall in our intervals? So I look and I have a 2 here and I have a 2 in this interval. The big difference is this 2 is equal to and this 2 is not. So that means 2 is actually included for this equation. So to find f of 2, I'm going to substitute 2 into the equation 10 times x minus 1, so that'll be 2 minus 1 when I substitute, plus 16. 2 minus 1 is 1, 1 times 10 is 10, and 10 plus 16 is 26. But what does this 26 mean? As of right now, we don't have as much context for it as we actually need. We know it's a distance, but we don't know what it's measured in. We can make some small assumptions, I would imagine, just because 26 feet would not make much sense because we've been biking for 2 hours. If we've only gone 26 feet in 2 hours, we have not been pedaling very good at all. So we might think maybe miles, maybe kilometers. That might make a little more sense. But all we can say definitively is that they traveled 26 as their distance. How far have they traveled in 3 hours? Write the answer using function notation. So function notation would be something similar to this. So I want to find the f of 3 because hours is the input. Just as we previously had to, we need to figure out which equation would we actually use for that. I see a 3 here and I see a 3 here, but this one doesn't equal. And this one does equal. Into this third equation. So 14 times x minus 2, which would be 3 minus 2, plus 26. So 3 minus 2 is 1. 1 times 14 is 14. And 14 plus 26 is 40. Again, I don't know what my unit of measure is for this, so it's just my distance. We can say units, but we don't know whether it's miles, kilometers, meters, so we're just going to have to leave it at that. What is the total distance that they travel on this bike ride? So we need to think if it's the total distance, that would be the whole trip. Based on this piecewise function, we determined that our domain only goes to 4 hours. That must mean that that's the end of the trip. And if that is the end of the trip, then I need to find f of 4 to figure out how far did they actually go for this whole trip. F of 4, it is included here, so we're going to substitute into the last equation. 12 times 4 minus 3 plus 40. So 4 minus 3 would be 1. 1 times 12 is 12. And 12 plus 40 is 52. So a total distance of 52 for the entire bike ride. Next, sketch a graph of the bike ride as a function of distance traveled over time. In order for us to graph this, we're going to need some graph paper. So for our graph, we want to make sure that we know what our axes stand for. So we know that our axis down here is time, and it is in hours. And we don't know actually what this unit is, but we do know that it is representing distance. So we want to do our distance over time, and in this case it's going to be in hours. And we need to do our piecewise function. So things to remember are that the intervals are a big part. I'm not going to graph this whole line. I'm only using a piece of it. I'm not going to graph this whole line. I'm only using a piece of it. So when we go through, we want to make sure that we divide up our pieces. I'm a visual person, and so I need to give myself some kind of visual cue to know where my pieces are. So my first interval is just from 0 to 1. So I'm just going to give myself a little highlighter dash line here, so I'll know that that's one interval. The next interval is from 1 to 2. So I have another interval here. And then I have another interval from 2 to 3. So I've got an interval here. And then our last interval is from 3 to 4. So I have 1 interval, 2 interval, 3 interval, 4 intervals. We also have 4 pieces, so that seems to work out pretty well. All of these are straight lines. They all have a slope, nothing squared, nothing, no exponentials or anything like that. We just have straight lines. So it's just a matter of graphing all 4 of my lines. So my first line starts at 0, 0, and it has a slope of 16. So I look at my scale over here. This appears to be counting by 2s, and then this is counting by 0.2. So I want to make sure I count by the right thing. So I'm going to go up 16 and over 1. So 2, 4, 6, 8, 10, 12, 14, 16, and over 1. That would put me right here. So the first piece of my graph is this little straight line segment in the first interval. Now I can check that one off and I can move on to my second interval. So this one does not start at 0, 0. Remember, point slope form. This one has shifted to the right 1 and up 16. So instead of being at 0, 0, I go right 1 and up 16. Notice that this one starts where the other one ended. That means it's continuous. There's no gap. That's always really nice. Our slope is 10, so we want to go up 10 and over 1. 2, 4, 6, 8, 10, and over 1. And this gives us our second piece of the graph. They almost look like a straight line. This one's just a little less steep. So we have one piece and then a second piece. Now I can check that one off my list and I can move on to my third piece. So my third piece is also not starting at 0, 0. It's shifted 2 to the right and up 26. So instead of 0, 0, 2 to the right and up 26. Again, the end meets at the beginning, so we are still continuous. It is a slope of 14, so I'm going to go up 14 and over 1. 2, 4, 6, 8, 10, 12, 14 over 1. So this gives us the third piece of our graph. 3 pieces down, 1 to go. So this one also is not at 0, 0. It's going to go to the right 3 and up 40. So right 3 up to 40. And then it has a slope of 12. 2, 4, 6, 8, 10, 12, and over 1. And so that gives us the last piece of our graph. So when graphing piecewise functions, you want to remember that you take one piece at a time. I'm going to graph this piece, graph this piece, graph this piece, graph this piece, and then together they make the piecewise function.